got your quiz. I'll talk about it in a second, but I want to review some of the stuff. So I gave you a little cheat sheet. No, you don't worry about number 3. That's coming up later on in the unit. All right, that's what we'll do on Friday. That's not part of the quiz. All right. So I want to at least go over at least the first 2 here. All right, the first 2 here. Okay. Probability and A and B, we went over yesterday in class. A and B. I'm going to multiply those 2 probabilities. Okay, multiply. And you already, even if it doesn't say the word and, which some of the times it won't, if you're replacing or not replacing an item, you got to multiply. Okay, keep that in mind, because a lot of these problems we do, you won't see the word and, but you'll see, hey, I put it back in my pocket. I eat it. All right, whatever the case is. All right, so with or without replacement, you're going to multiply. You can have a dependent or an independent. Those are 2 we went over yesterday. Dependent, the second one depends on what you did the first time. So right now with you, I'm going to do probability you draw 3 aces out of a deck of cards. 3 aces out of a deck. All right, assume, remember, nothing's there. Assume we don't replace it. Okay, assume we do not replace it if nothing is stated. So here we go. First ace out of the deck, probability. 4 out of 52. Okay, again, I'll have the deck of cards up here tomorrow if you need help with it. All right, I don't replace it. This is why it's a dependent, because I'm not replacing it. So the next one will be affected. Next ace. Okay, we got a quiz tomorrow. I'm going to be ready, all right, and confident that I have enough to get you guys ready. 6. Second ace coming out. What's the probability?
It's going to be 3
Yep.
out of 51.
3 aces, 51 cards. And a third ace coming out of the deck of cards. A third ace. Here we go. 13. Third ace. What's it going to be? 2 out of 50. Yep. And then you can use your fraction template, or again, if your calculator's not going to leave it as a fraction for you, just multiply all the numerators and all the denominators. Okay? We're trying to teach here, guys. Throwing that out there. Thanks. Okay, all good there on the first one. Second one, independent, meaning the first one has no effect over the second one. Face card, a 5, then a face card with replacement. Okay, so draw me a 5 first, replace it, then give me a face card. And a face card, Jack, Queen, King. All right, Jack, Queen, and Kings. All right, so what's the probability I get a 5 out of the deck? A 5. Here we go, 5. 4 out of 52. I put it back in the deck, so there's still 2 cards. And I won't ask anybody this one, but Jack, Queen, King for 4 suits, there's 12 face cards in the deck. And then I find the probability. So if you do not replace it, they are dependent. If you do replace it, independent. Because the last 3 or 4 questions on tomorrow's quiz, I'm just going to give you a scenario. I do not want the probability. All I want to know is if they're independent or dependent. That's it. You just write either word, independent or dependent. And let's just say if you get them flip-flopped, not going to get anything right. All right? So a couple questions tomorrow. Here's the scenario. Don't find the probability. Just tell me if it's independent or dependent. Questions there on and. Replacing or not replacing. All good. Dependent, independent. Go. I'll go over it in a second. I don't have the time right now. Everybody good? All set so far? Okay, next up. Or. We went over yesterday. Or now I want to add them. And then if it's possible, subtract out what's in common. Okay, so here you go. Back to the deck of cards, a jack or a queen. Jack or a queen. So I see the or. I know I'm going to add. Jack, how many are in the deck? 4 out of 52. Plus queen. How many queens are in the deck? 4 out of 52. Now you have to stop and think on an or. Stop. Is it possible to get both on the same card? No. That's why we say they are mutually exclusive. They cannot happen at the same time. All right? Picking a jack or a queen cannot happen at the same time. Mutually exclusive. So that's going to be 8 out of 52. Whatever that reduces down to, I'll take as well. Questions there? Mutually exclusive. They cannot happen at the same time. All right? Cannot happen at the same time. Versus this next one, which is not mutually exclusive, and you can tell me why at the end of this. 8 or a heart. So you see the or? Plus, here we go, 8. How many 8s are in the deck? 4 out of 52. How many hearts in the deck? 13, but now you got to stop yourself because you've counted some cards twice. How many cards in the deck are both 8s and hearts at the same time? The 8 of hearts, right? And you just counted it twice, so you got to subtract 1 out of 52 for the 8 of hearts. So what's that? 16 out of 52, whatever that reduces down to. And again, those are not mutually exclusive because they have something in common. A lot of kids get confused with these here, mutually exclusive versus not. Mutually exclusive, they have nothing in common. All right, nothing in common. Cannot happen at the same time. And again, number 3 we'll worry about on Friday, not right now. Anything on this quick summary? Because that's part of the quiz tomorrow, is this. Anything you want to ask there? Before I get to the makeup of the quiz, is there anything from last night that you guys tried? Again, I'm telling you right now, if you're not trying them, I can't help you. I can't help you tomorrow if you're not practicing some of this. Okay, anything from last night you tried and you're like, ooh, that might be a little bit out of my league. I need a little help with it. Here's your, because I'm not going to select, I don't have time today to select one and do it for you. All right, unless you have actual questions, that's the only thing I'll answer. I'll be after today if you want. I'll be here 3rd period tomorrow. I won't be here 4th period, but I'll be here 3rd period tomorrow if you want to come in and get ready. Anything from the assignment yesterday? If not, these are all great questions that are just like the quiz. Okay, nothing. All right. I can suggest it, but I can't force you guys to do it. So here's the makeup of tomorrow. 31 points, 12 questions, first six are multiple choice. Okay, first 6. I've told you already I'm going to give you 2 events. Are they independent or dependent? And then I'll ask another 2 events. Are they mutually exclusive or not? No probability. I don't want to know what the probability is. I'm just going to say, all right, I have I have 6 coins in my pocket. I pick one, replace it, pick another coin. Independent or dependent. Okay? Straight up. That's all I need written down. Independent, dependent, mutually exclusive or not. What we do on today's class here is will also be on there tomorrow using a table to get probabilities. And then this is exactly what I just went over with you on your cheat sheet, your summary sheet. Okay? So there's tomorrow's quiz there. I will not ask you to do any tree diagrams. If you need one to figure out the probability, you are certainly allowed to draw your own, but I am not going to require any tree diagrams tomorrow. Let's go tomorrow. Start today. We're all good? Everyone's got a calculator in front of them? Okay, here's what I want to do today. I'm going to give you a table, and I got questions off the table. That's it. All right, we're still going to do some of the stuff we did yesterday with it, but I'll leave that up there if anybody wants to keep copying. Go ahead. Let's get to today's topic. Reading a table. That's all I'm going to ask for you here. Reading a table. So you see the first about the pet store coming up. Okay. So number of pets on top. How many people have those number of pets? So you see what the table, do you understand the table first before we answer any questions? So basically there's 37 people who own a pet, one pet. 9 people own 4 pets. What's the probability I choose someone that has 2 pets? Probability I choose someone who has 2 pets. So I'm going to go start with my symbols. P for probability, 2 pets. Okay, how many people have 2 pets? First, that's got to go on top. Let's start this off right. 11, go ahead, start this off right. How many people have 2 pets? 33 out of, is it 100? Yep, out of 100. And then if you guys don't know where the 100 came from, I added up the number of customers at the bottom. Art. No, I just want you, if you see it, I want you to know what it means. I'm not going to force you to write it like that, no. But if you see it in a problem, you should know what that means, yes. All right. At least 3 pets. What's that mean to you guys? At least 3. 3 or more or less, at least. You have at least $3 in your pocket. What's that mean? 3 or more. Okay. So add them up here. 3 or more. What goes on the top? 3 or more. How many? 7? Yes.
Yeah, 7.
There's only 7?
For the pet.
3 or more. How many people have 3 or more?
Oh, people, not the pet.
Yes. 3 or more.
Oh, 27.
27 out of. There you go. All good. All right, now you're going to start getting introduced to what's called a two-way table. Meaning you got some information on the left, some information on the top. So on the left are people going to college, not going to college. On top is their genders. All right, is their genders. Now it gets a little bit more tricky. So we're going to pick a student at random, female and going to college. Can we figure out where those meet? Female and they have to be going to college. According to my chart, how many exist here? Female and going to college. 3, how many exist in the chart? Female going to college. 13, everyone see it right here? This is where Jill's looking at, 13. Okay, out of, okay, I do want to pick the 52, yes, because it says, ready? Was it probably that a person picked out? So I'm going to everybody. All right, I'm going out of everybody. So 13 out of 52. If you want to reduce it, reduce it. You guys good so far? Because now it's going to get a little tricky. Probability you pick a student would be female. Oh, hey, look at that. Or someone going to college. It didn't say and. I just answered that question. Female and going to college. It's female or going to college. So let's start with the females. How many females are in this chart? 20. And that's where Art got it, right here. 22 out of. Oh, a person. I'm talking the whole thing. 22 out of. Oh, 52. Yeah, you're right. Never mind. I don't know what I was thinking. Sorry. What do I do with the ors? Okay, so plus. Now I'm looking for what now? Going to college, which is, according to the chart, how many are total are going to college? 29 out of 52. But what, Jenna?
We need to subtract 13.
I've counted a couple of the females twice. Because they're female and they were going to college, I've counted some females twice. So I have to subtract out what? How many are female and going to college, which we just found in the last problem was 13. So you still have to subtract out what's in common. And what do we end up with there? 38 out of 52? Questions, specifically why we subtracted out the 13 out of 52. Or remember, I add them and subtract out what's in common. How do we feel here, all right? Okay, I'm going to ask more questions out of you guys now. Oh, here we go. Right up our alley, huh? Males and females, who wants a live band or DJ at the prom? The only thing they didn't do for you is what? Yeah, there's no total column. So sad. So sad, seniors. They didn't put a total column. Randomly selected student, so we're going out of everybody, wanted to have a DJ at the prom. Randomly selected student wants a DJ at the prom. So you're going to have to do your own totals here. All right, got to do your own total. How many people wanted a DJ? 13. How many people wanted a DJ? 237 people. Out of, remember, this is students now, so all students. All students there. Out of, what's the total number of people there? 9. What's the total number of people I have in that chart? Sure. I think you added a couple extra there. 462?
Oh, out of all the DJs?
No. All the students. There's 103 students that are male and want live band, 102 that want DJ and are male. So I'm adding up all 4 here. 460? Yeah?
I got 435.
I have 435. Everyone all right? And then part B, probability, you select a student. So we're still at the students. I know I'm harping on that, but that'll change in part D. Both male and want a live band at the prom. Male, live band. All right, so first 7, male and live band. How many? 103 out of how many students? Still 435 because I'm picking from the whole group of students. That's going to change in a couple though. All right, part C, we got to do a little extra work. Female or DJ. Female or DJ at prom. So let's start with the female part. How many females do we have here? Got to do a little adding yourself here. 8. How many females do I have in this whole chart? 230. How about I'm on the right one? There you go. 230 out of 435. Or tells me I'm going to do what? Add. Now give me how many want a DJ. And this is regardless of gender. How many want a DJ? 237. Anybody going to tell me to watch out for something here? I have to subtract out the ones that are female and want a DJ. 100 and DJ female. Again, why are you subtracting these out? Because you've counted them because they were female and counted them a second time because they wanted a DJ. Only can count one person once. 332 out of 435. The only thing I worry about is the or. Make sure you add and subtract out the what's in common if there is something. All right, ready for part D? This is why I've been harping on every time. Ready? What's the probability of randomly selected student? So we've been doing everybody. But now take a look. What changes in part D? What's the probability of randomly selected male? So it's not going to be out of 435 anymore. All right, I'm only going from the males. All right, wants to have a DJ at the prom. All right, well, let's look at our chart. How many males want a DJ at prom? 102, but it's not out of 432. All right, it's not out of 432 anymore because now it's a randomly selected, not student, but male. So 102 out of, how many males are present? 11. How many males are present? 205. Everyone see the difference there? You select a student, yes, now it's out of everyone, but now it's out of the males only. So 102 out of 205. Anything from you guys? Going. Okay, I know I changed the packet up this year, so I'm going to have, not that. I got rid of that. You guys here? Right?
Yeah,
Okay.
that's the problem, though.
What's that?
We have that other problem.
It doesn't start with this one, the next one?
That's what I have next.
Yeah, it's this one.
Right?
Yeah. Oh, I guess I.
Okay. It's number 4. Maybe I didn't put the new one on there. All right, so now you fill out your own now. Fill out your own two-way table now, based on the info I give you. So here we go. Good old Joanne. She's a go-getter. Oh, she wanted to know who's attending the spring fling. 66 freshmen responded. Where do I put the 66? Total. Well, I got a lot of totals here, guys. Oh, all right. With 32 saying they would attend. So 32 freshmen attending. Got it. Of the 84 sophomores, so 84 sophomores, 46 said they would attend. And I think I've given you enough info to fill out the rest, right? How we look up there? All right?
Yeah.
Everything filled in? Okay, I see some of you guys trying to get ahead and you're falling into the trap I thought you would fall into. How many students responded to the survey? Okay, nobody fell into that trap. How many students surveyed said they were attending the dance? Okay, it's not a probability. I have this. Some of you guys have this, 78 out of 150. That's like a fraction of a student attending. Okay, everyone see it. I'm not asking for the probability. I just want to know how many. Everyone see the difference? Just says how many students. So just 78 students. That's it. Okay, now not what's the probability. I didn't see the word probability. And then how many of the surveyed sophomores are not attending? 38. Not 38 out of 150, just 38. Okay? Bless you. Probability, I'll take the fraction what it's out of, but not this. You guys feel comfortable with that? Good. Okay, do you have number 6 there created into a relative two-way table?
Yeah.
Okay, I'm not doing that. You're not going to be responsible for that. That's just a waste of time, so you can put a big X to it. It's a waste of time for us. There's no need. Okay, just another fill in your own table now. A lot of reading here in Milwaukee, Wisconsin. Asthma, members of the House smoke. Okay, they don't, at least one. All right, so here's where the meat is. The probability of randomly selected student at the high school having asthma was found as 0.193. Where should that 0.193 go? The probability of a selected student having asthma was found to be 0.193. Total student has asthma, 0.193. Now that's not how many students, that's just the probability. All right, that's what we're filling in here is the probability, not how many. All right. So part A says now, what, oh, and there's another one, isn't there?
Yeah.
Students were also asked if they had at least one member who smoked, reported to be 0.421. So where's that going to go? At least one household member smokes. Where am I putting? I got 3 options. Total, yep. Okay, real quick, part A. When I gave you the 0.193, what other probability could you find? That's what it's asking for right now. Just the 0.193. Given the 0.193, what other probability in the table can you find? Total. Total for what?
Students who don't have asthma.
Yep. It's total for student does not have asthma. Okay, just by giving you the 0.193, you can now find that total. And then when I gave you the 0.421, what other probability could you find?
He doesn't have a member that smokes.
No house total for? Which total? I guess there's only one left, right? No household member smokes. And then part C, I'm going to give you one more probability. At least one household member who smokes and has asthma. So can you figure out where to put that 0.120? Has at least one household member who smokes and has asthma. So it looks like we're going to put it right here. 0.120. So what other probability can we find now? Let's make this easy. What can we fill in the rest of the table?
Yeah.
Okay. So rest of the problem, please do so. And we'll compare our answers, and then I'll let you guys get to work. no household member smokes, student has asthma. Point. Student doesn't have asthma, no household member smokes. 0.506. Total, no household member smokes. 0.5.
7.9.
Good. One household member smokes, doesn't have asthma. 0.3. Got it. And then total doesn't have asthma. Good job. Okay. Couple things about your assignment you're about to do. I will never ask you to create your own two-way frequency. I just want you to fill it in. So if you could go to number 2, question 2. Go to question 2, where it says Heather sent out the survey, right? Am I on the right one? Correct, Heather? On number 2. All right. Here's what the two-way table looks like. So you don't have to fill out. You don't have to do your own, but you do have to fill it out for me. So on the left, you're going to have male, female, total. And up top, you're going to have yes, no, total. And then based off the info they give you, you're going to fill it in. No, just filling it in. No questions after it. And then go to number 3 when you're ready for number 3. And you have this copied down. We got another table you got to do for me. I'll make this a little smaller. While you guys are copying this down for number 4. Okay, on the left-hand side, you're going to have managers. I got staff. And I have assistants. And then total. Up top, you want to do potluck. You want to do restaurant. Oh, we got other options. You can do gift or gift exchange. Total. And you do not have to do part B for this, okay? You do not have to do part B. Just part A, which is create it and fill it in. So go ahead, get going. I highly recommend too, you get that done within the class ending. Go back to yesterday's, get ready for the quiz.